Chapter 3, Describing Data Using Numerical Measures. In this chapter, we continue our conversation around descriptive statistics. So make sure to download the Chapter 3 Practice Problems worksheet from Canvas so that you can follow along with the lecture. In this video, we'll cover the mean, median, mode, and weighted mean, as well as the box and whisker graph. Recall in Chapter 1 that we discussed what a parameter and a statistic was, where a parameter is some measure that we compute for an entire population, whereas a statistic is a measure that's computed for a particular sample. So here we have the measures of center and location, mean, median, mode, and weighted mean, that we could be calculating for a population or for a sample. So let's start with the mean. Here, a mean is a numerical measure of the center of a set of measures that's calculated by adding up all our values and then dividing by the number of values in our data. Essentially, you're calculating the average. So you'll notice that we have two formulas, one for the population and one for the sample. They are similarly structured, except that they use different Greek letters so that you know, hey, I'm working with the population or I'm working with the sample. So here, our population mean is denoted by the Greek letter mu. That looks like a U. And then the formula instructs us what to do. In this case, we will add, this is the Greek symbol for summation, we will add all of our x's up and then divide by big N, which means our total population size. Over in the sample mean, similarly, we have x bar, which tells us that we have a sample mean. And similar process, we have our summation symbol that tells us we will add up all of our x's, and then we will divide by our sample size, our little n, because our sample size is smaller than our population size, hence little n, big N. So it's really important to learn these symbols because you're going to see it throughout the semester, and it will be a lot easier for you once you've mastered what each symbol means. So let's do a practice problem. This is number 4 in your textbook. It's also on the worksheet, so follow along. Feel free to pause the video as you're doing the calculations so you can try it out before you see the answer. Here we have the time in seconds that it took 16 cars to exit a parking lot in downtown Cincinnati. The first thing we want to do is find our sample size. Fortunately, the problem tells us that our sample size is 16 cars. But if the problem wasn't so kind, you would have to count how many data points you see in the data set. So I could count 16 here in the table. Next, we'll go ahead and compute the sample mean. Here's our formula, where it tells us the first thing we'll do is add up all our values. So I'll use a calculator, for instance, and I will add up all 16 data points in my table here, and I will get 1,873. The formula then tells me that I need to divide my numerator by a sample size. In this case, the sample size is 16. Using my calculator, because I can't do this in my head, I'll determine that the sample mean, when dividing 1873 by 16, is 117.0625. Calculating the population mean is a similar process. The formula just looks a little bit different, but it's the same. Let's move on to the median. The median is a center value that divides a data array into two halves. What is a data array? This is where we take our data set and we'll arrange it in numerical order from smallest to largest. To calculate the median, you also need to calculate the median index. So this I, or the index, is going to tell you the position of where our median is within our data set. And that's this formula right here. You also recall that our little n is our sample size. So to find the median index, we will take 1/2 of our sample size. We're taking our sample, ordering it, and cutting it in half and finding that midpoint. So step 1, we'll collect our sample data. In step 2, we'll organize it from small to large. Step 3, we'll use that formula on the last slide to calculate our median index of I. And then, depending on what I turns out to be, if our index is not an integer, meaning it's not a whole number, we round up. If our index is an integer, then what we have to do is find the position where I falls, the whole number, and take the average of that number and the next number up, or I plus 1. and we'll see an example of it in just a sec. Based on our index, we can then find the corresponding median value in that particular position. So here it continues on with problem number 4. We're going to still use the 16 cars. Again, your worksheet has the table in front of you, so I'm not going to redisplay it here on the screen. But our task is to sort the data from small to large. So once you've sorted your data from smallest, 51, to our largest of 169, we then want to compute the median index. Our n is 16, so I'll plug in 16 into my formula and multiply it 1/2 times 16. That'll give me a median index or position of 8. So because 8 is an integer, I'm going to want to average the value in the 8th position and the next number up. So since I know I'm looking for the 8th position, I'm going to go back up to my data set. And so the 8th position in my data is 125. And I want to take the average of 125 and the very next number up in my data set, in this case 128. So again, to take the average of anything, we add our values and divide by the number of values that we see. So we do 125 plus 128 divided by 2, because there are 2 values. This will give us the median of 126.5. Now let's talk about the mode. The mode is a number in our data set that occurs most frequently. It may not always have a mode in our data set, but when there is, we want to find out. So here is our data set, for instance. And so at a glance, which number appears most often? Because it is a small data set, your eyes will look through and can probably pick out the number pretty quickly. But if you were working with a large number of data, then we would have to sort it, as you see here on the right, and count up the frequencies, and then we can see here that yes, 20 appears most often. Therefore, it is our mode. So now that we have talked about what a mean, median, and mode are and how to find them, we also need to understand the relationship with each other. When our mean, median, and mode all equal the same number, we are experiencing a normal curve, and that means we have a perfectly symmetrical distribution. If our mode is greater than our median and greater than our mean, so you can see where they fall, for instance, on our curve, then we have a negatively skewed distribution. Here on the right, if our mean is greater than our median and greater than our mode, so here we can see the position where my mean is far to the right, my median's here in the middle, and my mode is the smallest of the 3, then we are positively skewed, so that our distribution is moving in a positive direction. Now when we look at these 3 measures, the mean is generally used unless we've got extreme values or outliers that exist. So extreme values or very large or very small numbers can skew our data and make it less useful. Then the median is next oftenly used since it is not sensitive to extreme values. So for instance, if you've ever heard median home prices that are reported in the San Diego County, this is less sensitive to outliers. So those fancy mansions that are very expensive would be left out, and it focuses on what home prices are in the center or in the median. And then the mode is good for determining what's more likely to occur. Let's also talk about the weighted mean, in that sometimes we can't just take a simple average like we did earlier with problem number 4. We would want to use a weighted mean because some of the values have more importance than others. And you'll notice whether you're doing the weighted mean for a population or a sample, it's the same process. It's just slightly different symbols so that you know you have a sample versus a population, where W is the weight of our data value, and then X is the actual value we're working with. So the first step is to collect our data and determine the weights that you'll assign to each value. Then we'll multiply our weights by our data values and add them up. Then we will add up our weights for all our values, and then use the numbers in step 2 and 3 to compute the weighted mean. So let's look at an example. Here we have the La Costa Corporation that operates 5 manufacturing plants in South America. The company tracks medical costs that are directly attributed to accidents that occur at the plants. The following data in the table below show the medical costs at each plant along with the number of employees who work at each plant. So let's go ahead and calculate the weighted mean. To do this, we're going to multiply our variable of interest, in this case our medical costs. This is what we're interested in knowing. And our weights are the employees. So we'll multiply each value by the weight and then bring that down and add them up to get our numerator. That's where this summation symbol says, take my W, multiply my X for each value, and then add them all up. So here I've multiplied each value by its weight, and it gives me a number here. I will repeat that 5 times and then add these numbers up to get my numerator in my formula. The formula then tells me I also have to add up all my weights. So recall the employees are the weights. So I will add up my 5 numbers here from my table. So then what I'll do is I'll add up all my numbers on the top and then divide it by the sum of my weights down below. And that will give me a weighted mean, 11,213.48. So our next question is, why would La Costa want to use a weighted average rather than a simple average of the medical costs? So it's logical that plants with more employees would have more medical issues, right? So the weighted average takes into account the number of employees and is more reasonable than if we treated all plants the same. That way we can make sure certain plants received services, funding, or medical professionals to support that plant. So when we're working with percentiles, it's essentially providing you the location of data, where if we list P%, these are the values that are less than or equal to this value. Whereas if we do 100 minus P%, this is the data that's greater than or equal to this value. Note that our median is the 50th percentile because it's right in the middle. So for instance, if I say 30 percentile, I'm essentially saying these are the values that are in between 0 and 30% of my data array. In terms of quartiles, think quarters, we're dividing by 4. We're taking our data and organizing it into 4 parts. There'll be the first quartile, which covers the first 25%. Then we've got our second quartile, which covers up to 50th percentile. This is also where our median falls. And then our third quartile, which gives us up to our 75%. So you can see the relationship between percentiles and quartiles. In that quartiles, there's only 3 that we're specifically looking at, and they fall at the 25, 50, and 75 percentile. Whereas if I'm looking at percentiles, I can get very specific. I can get to the 33 percentile, 71 percentile, 82 percentile, anything between 0 and 100. So to calculate percentiles and quartiles, we again want to sort our data from lowest to highest, and then we have to use our location index. This should sound familiar because it's similar to what we did with the median. So here we've got our I, where whatever our percentile we're interested in finding is, will be divided by 100, and then we multiply by our sample size. Similarly with quartiles, our Q, whatever our quartile is, first, second, or third, and what that means, 25, 50, or 75, is plugged here on top and then multiplied by our sample size. Now, same rules. If our index is not an integer, we round up to the next whole number. If our index is an integer, is a whole number, then we average whatever number appears in that position I, or the index, and the next number up. So here's our example in problem number 4 again. Same 16 data points. Here we want to calculate the first and third quartile. So by definition, the first quartile means 25%. And so I'll plug in my 25 for Q, and my N is still 16. So I'll take 25 divided by 100 times 16. This gives me my index of 4. So I'm going to look for the 4th position on my data array. Recall though that if my index is an integer, I have to average whatever number appears in the fourth position and the next one up. So if I look at my data array down below, and it's already organized from smallest to largest, which you did earlier, my fourth position is 100, and the next number up is 101. So we'll go ahead and take the average of the two by adding 100 to 101 and dividing by 2 to get my first quartile of 100.5. Next, let's do the third quartile. Again, third quartile by definition means 75%. So I'll plug in 75 into my Q, and my N is still 16. So when I take my 75 divided by 100 and multiply by 16, my location index is now 12. Again, because it's an integer, I'm going to find whatever number is in the 12th position and average it with the next number up. So I look at my data array down below. The 12th number and the next number up is 135 and 139. So I'll take the average of those two numbers, and that gives me a third quartile value of 137. Note that when doing it by hand like this versus doing it in Excel, your numbers will be slightly different. Last but not least, here is a box and whisker plot, in which the box and whisker plot is a graph composed of a box and whiskers. The box is based on the quartiles that we have calculated earlier. For instance, the first quartile and the third quartile. Then the median cuts through our box. To get the lower and upper limits, we'll take 1.5 times the difference between our first and third quartiles. And then if you have any outliers, meaning extremely large or extremely small numbers that are not within our limits, you will plot small asterisks like you see here on the screen. So here's an example of a box and whisker plot that you might see in Excel. And if you want to learn how to use Excel 2016 to create box and whisker plots, please make sure to check out the Excel tutorial that supplements this. If you have any questions, just let me know.